What's up? It's Neil for Real here, bringing you another awesome video. Today we're digging fluorescent opal and testing it for safety, just in case. Opal.
Fluoresces bright green. I was told it's uranium that makes it fluoresce. A little dark out here today, but it's eroding. That's the vein right there. Common opal. Background is like 35 or 30, so it's double background. So, all right, we're down to about background 30. Background, that's better.
Today we explore an opal exposure I noticed while rock hounding for agates a few years ago. There are large white shiny pieces in the road. After examining a small piece of the white shiny rock, I realized it was opal.
It's up there. All right, check this out. This is the opal exposure. These little pieces coming down the hill. Let's see if I can get to it today. Let's see what's up here. It's really steep. Must have had I don't know, some sort of wind event. There's just pieces of tree all over the ground. Got a vein of opal coming out of the hillside over here. So that's the opal, a ton of it. But it's eroding out of this hillside. It's real sketchy up here. It must be right here under my feet. You can see the vein right there. Maybe.
Now's a good chance to explain what I'm doing here. I'm checking out the surface and past workings to locate the strike and dip of the opal vein to decide where to dig. This looks like a good place to dig and figure out if it's worth it to explore this area further. I'm looking for large pieces of rough opal that are loose on the surface, or preferably in situ or still attached to the host in the place where the opal was deposited. The strike is the orientation of the vein on a compass direction wise. So if the vein is running like north to south or east to west or any angle in between, it's represented by a number, a degree. 360 degrees is all the way around. So you can do the math. The dip is the direction and angle of the vein deposit or occurrence into the ground. This vein is approximately northeast to southwest strike trending, northeast dip. Kind of like if you're looking north, the vein is going to be trending down into the ground at a 45-degree angle towards the northeast.
Check out this common opal.
On the surface, you can see it kind of traveling northeast to southwest. You get it? All right, next.
Fluoresces bright green.
Opal. So, you know,
background. Dark out here today, but it's eroding. That's the vein right there. Common opal. It's real steep right here. Got a nice cliffside. Real cool area. I'm just checking this out. I'm digging right here because it's too hard to get out there. This is a pretty steep cliffside. I need two hands. Ooh. Yeah, it's coming up right here. Oh yeah. There's some chunks. Some of it's fiery orange. Common fluoresces bright green. Maybe there's some flash here somewhere. You need full sun and get that mud off of them. Pretty cool. Found some pretty big chunks. It's my first time digging here though. I really don't know what's under the surface, but I must be close to this vein. Yep. Yep. Yeah, something. Hopefully. Alright, I'm digging on this vein a little more, finding some good little common opal. See those little bubbles? This stuff fluoresces bright green. Here, that's the uranium. Depleted. Not dangerous. It's coming out of this vein. Host rock. Yeah, that's the host. The vein higher, mixed. Alright, I'll check in with you later. Woo! Pretty steep up here. On the darn cliffside. Cliffside, Colorado Opal. Check you later. Check it out. It's eroding from this hillside. There's the vein. There of opal. So I'm here on this crazy cliffside. Yep, that's the road right there. Real cool area. In Colorado. Found a few larger pieces. I'll show you a fluorescent video later. Digging right here because I'm following the vein. Yeah, I can't get out there, it's too steep, so see how this goes. I'll see you later. All right, see what I'm doing? It's here. Dig it up. My feet are hurting. I'm squatting, so let's move a little bit more somewhere. Really don't want to be digging above the road right here, so make sure there's nobody around. Yeah. Alright, let's do some exploring. I see some big pieces there, but it's hard to get to. Probably need some ropes. You'd think it'd be over here somewhere too, but I don't see it. This dirt is so soft. Opal though. Somebody tried to dig down to it. That's exposed here. Wow. It's a ton of it. Wow, this whole surface. Common opal. Oh yeah, this whole area is just fluorescent, I'm sure. See how some of it's red. I don't see any flash in that piece, but that's how big. It's a bigger one. That one, it's waxy. Oh yeah, that's a big one. Yeah. Okay, I think we might have some cuttable pieces. I don't know if I want to cut this stuff if it fluoresces as bright as it does. It's cool sample stuff. Let's just see it eroding. The vein goes that way, so I'm just standing on the vein here. There's tons of it. A lot of just that milky common stuff. Just a ton. This whole pile. Opal. Bubbles. Some of it's a little fiery rosy. But how? So much. Let's go. Pretty good. Just white, milky stuff. Gotta be careful here. This is a big cliff. That's what I'm seeing. That's the exposure.
Now that I have your attention, opal, hydrous silica, often with some iron and aluminum. SiO2NH2O. Amount of water varies up to 10%. I think that's the N is the number of the amount of water, so that varies. Color and luster: white, yellow, red, pink, brown, green, gray, blue, colorless. What the heck? Frequently shows rich internal play of color. Opalescence in precious opal or fire opal. Vitreous, pearly, streak white. Hardness 5.5 to 6.5. It's pretty good. Specific gravity. Who cares? That's like density 2.0 to 2.2. Fracture, conchoidal. Conspicuous when compact. Transparent to translucent. Fluorescent. They should have an exclamation point on that. Crystals, none, usually massive. Reinform. Stalactitic. Earthy. Best field marks: vitreous or pearly luster, opalescence, conchoidal fracture, and brittleness. Definitely all that check. Dense opal resembles quartz, but is softer and has a lustrous conchoidal fracture. Opal is a low temperature mineral and usually develops in a wide variety of rocks as cavity and fracture fillings. It frequently develops as amygdals, that's like almond shape, in basalt and rhyolite, a volcanic rock. Duh. So basalt and rhyolite, this is more possibly an andesite, which is in between your intermediate rock, in between basalt and rhyolite. All are extrusive igneous volcanic rocks. Opal. And replaces cells in wood and the shells of clams. Common opal is widespread and can be readily obtained at many places, but localities for precious opal are rare and seem to be localized in western United States and Mexico. Magnificent examples of opalized wood can be found in Idaho, Nevada, Oregon, Utah, and Washington. And lively green fluorescing opal highlight occurs in seams and pegmatites in New England and North Carolina. Beautiful precious opal as a replacement in wood has been obtained in Virgin Valley, Humboldt County, Nevada. Black, dark blue, green opal with dark gray body color and fine play of colors is called black opal. Opal with white or light body color and fine play of color is called white opal. a transparent or translucent opal, color ranging from yellow, orange, yellow, and red, and a play of colors is called fire opal. Play of color depends on interference of light and is not dependent upon body color. Black opal is the most highly prized, and fire opal is the most valued of the orange and red varieties. Most opal is fashioned into cabochons, but some fire opals are faceted. Nevada, Australia, and Honduras are sources of black opal. Australia, Czechoslovakia for white opal, Mexico, and Southwest United States for fire opal. Excellent fire and precious opal occur in lava flows in New Mexico. Ooh. Oh, wow. That's the opal science stuff. The word is from Sanskrit, Upala, upala, meaning precious stone.
This is that common opal again. We're here on the other side of the structure, and I'm finding lots of really waxy stuff. You can see how it kind of glows in the sunshine like agate would. But this is trying to dig here and expose the vein. You see all this is opal. The vein is right there. So it's gotta be here somewhere. Try not to fall off this cliff. But it's just really cool. Got a bag to take home and sample. Pretty cool. I'll show you how it fluoresces here soon. Alright. Oh, some of it's got a little bit of banding. There's a little bit of red. I don't know if you'd call it fire, but some orange in there. I've heard there is some flash out here, maybe some green. So using this sunshine, taking a look. Haven't found any yet. I'll let you know if I do. Alright, see ya. Alright, here you go. I'm out here at this same opal spot. And look, there's a blue agate. Well, chalcedony nodule, an agate would have banding. But this is the blue, the little blues. Check that out. Zoomed way in. But it only looks blue. It's like blue on the surface. Don't know what that's called, but that's pretty cool. They're like golf ball shaped. But see you later. Alright, another wonderful day out here. Picking up trash. Pretty cool flamingos today we got. What the heck, strawberry lit? What the heck are people doing out here? But another wonderful day. Cleaning up the forest. But enjoying it. Getting trash out of here. I think this is one of the first Mountain Dew cans ever made. But see you later. Alright, here we go. This is how I'm getting it done. We got the GoPro filming. I'm filming. And this is that opal. See how it looks kind of peach in the sunshine, almost kind of orange. Pretty nice looking stuff. It's got little bubbles in there. This is gonna fluoresce bright green. There could be some flash out there. I've heard there's some green flash. Not certain about that. There's the little, whoops. That looks pretty blue. And gray. Blue. Gray. Blue. That's pretty good. Bands in there, like wavy bands with bubbles. It's gonna fluoresce crazy green. Alright, here's the fluorescent video. We've got some bright green fluorescent opal. That orange is lichen. Those stripes are clothing fiber. Some of them don't glow all that much. Wow. That one's super bright. There's that agate. Agate not glowing. Another spot. Wow. Ooh.
Science stuff. I was told that the trace uranium makes this opal glow under the UV. It might be another associated mineral, I'm not certain, but this is what we got. It's bright green. So it's either depleted uranium, very light trace amounts. I check it with the Geiger counter. The Geiger counter test is extra helpful when extreme fluorescence is detected. It's pretty good fluorescence, so I figured I'd give it a shot with the Geiger counter. I got a Geiger counter, so use it. I got the Geiger counter to test the petrified wood. Fluorescence is a great indicator for potential radioactive minerals, rocks, and fossils. Let's see what the Geiger counter says. These levels are all safe to handle gently. Anything double background radiation I try to store outside and avoid cutting. This Geiger counter has provided a sense of relief in most cases and a ton of experience overall. Let's see what it said. And I did find some elevated levels in the petrified wood.
This rock is slightly radioactive. Guess what it is? Gotta let that snow melt off to find out. There's a little hint right there. Alright, background is usually around 20, 30, between 20 and 40 here in the High Rockies of Colorado. I'm surrounded by uranium mines. Whatever. So there's that. But these are not elevated levels. I have found some elevated levels in petrified wood and dinosaur bone. close. They're beeping at me. That's more than double background. So I use pieces like this to test to see if the Geiger counter is working. The GM 300E Plus Geiger Mueller counter data logger. Not a review or recommendation. I think I got this because I saw currently rock hounding using it. Seems to work. I have the highest petrified wood readings I've found are in the 300, maybe 400. I don't know when it starts chirping. Maybe I turn that off. But you can see that got all the way up to above 70. And background is like 35 or 30. So it's double background. So, alright, we're down to about background 30. That's better. Alright, now we're back down to normal. And here's all that opal from that opal spot. Some of these are from the ones the other day. This big one is from another nearby location. Very good chunk. Somebody said I should cut them in half. See, we'll see. I kind of want to cut this one. I mean, they're not radioactive. They're about background. Background. I mean, slightly more than sitting over there. But like I said, it'll fluctuate. I don't know why, but depending on what direction, it's real windy today. Depending on what direction the wind's blowing, background will fluctuate between 20 and 40. Like I said, depending on the direction the wind is blowing. Let's just move like 6 inches away. So maybe there's a subtle amount of the technical level coming off of these. The mystery rock outside is much higher. Put that back on there. Do a double test. I got all the way down to 22. 20. Ooh. Here's that radioactive mystery rock. Who knows what that is? Give you a hint, it was walking around at one time. Just a little piece of awesomeness. Alright. You guys have a great day. Peace.
I'd like to give a special thanks to everybody who watched all the way to the end and currently rock hounding cool videos. Keep it going.